from start. Okay, particle trajectory initial velocity 40I plus 50J. So we're going to write down the four equations really quickly. Vx always stays at 40. Vy stays at 50 minus gt. So 50 minus 9.8 times t. Using the formula v equals u plus at. Gravity is decelerating you. Sx is every second you travel 40, so it's going to be 40 multiplied by t. And then Sy, 50t, so it's, we're using the formula ut plus a half at squared, so it's going to be 50t, then minus a half of gravity, which is 4.9 t squared. Okay, we're going to stop there. Okay, now A and B are 2 points on the trajectory, so I'm doing this, I'm sort of drawing a graph here, okay, and I'm just drawing a standard, like, path of an arrow or any projectile. Feel with that? Now, particle reaches point A after 2 seconds, and the displacement of the point B from P. So I don't know if it's on the way up or the way down. Does that make sense? Both points could be on the way up. One could be on the way up, the other one could be on the way down. They could both be on the way down. I actually don't know, do I? So just for simplicity's sake, I'm just going to put A on the way up and B on the way down. And if I'm wrong, what will happen? The maths will show it. Okay, so the maths will show if I'm wrong. Okay. Now what we're saying about A is t equals 2. What are we saying about B? We're saying that Sx is 360. Oh, that makes things easy. Because what's 360 divided by
9.
Yeah, it's 9 seconds in. So we already know point B is actually 9 seconds in. And does everyone know how I got that? 360 divided by 40, because you're 360 in the horizontal direction. See that vector? 360i. That means 360 traveled in the I direction. Okay? Now, what's the deal with K? K is actually the height at 9 seconds. So how can I find that out? I know I'm doing it in the wrong order, but what can I do with the SY equation? Sub in 9, yeah, go on, let's do that really quickly and I'll do the other thing in a minute. Just sort of jumped out at us, didn't it? So we're going to find out what K is really quickly.
531 over 10.
What?
53.1.
53.1. 53.1. Does that do everybody? 53.1? Anybody else calculate it? 50 times 9 take away 4.9 times 9 squared? I just want somebody to verify. Anybody had to verify?
Yeah.
Great. All right. Now, sorry, did part 3 straight away. That's on me. Part 3 just seemed really easy. Just jumped out. Now, I'll go back to part 1. Find the velocity of the particle A in terms of I and J. Well, what do we know about particle A? 2 seconds in. 40 stays there. 40 stays the same. Yeah. But what about this one here? 50 take away 9.8 times 2. And what you get? 30.4. Now, it wants us to get the speed and direction it's doing. So this is where your trigonometry is about to come in for your Sandy. Ready? So it wants us to get the speed and direction. So check this out. Speed and direction, yeah? So you're going to do 30.4 this way, yeah? 40 this way. Can somebody do Pythagoras' theorem and figure out what x is?
50.24.
50 points?
2.2.
Yeah. That's your speed, yeah? Anybody care to tell me what the angle X is? Could you use tan? Opposite divided by adjacent. So what did I say about tan? Tan X is 30.4 divided by 40. Tan inverse it. What do you think? Texas term. 30.4 squared plus 40 squared, this here. Square root the answer. What do you get? 1 million is too big. So what you get when you tan inverse it? What? 37 degrees? Yeah. About 37 degrees? So it's going up at an angle of 37 degrees at a speed of 50.24 meters per second at that point in time. Okay. What's the last thing you're going to have to do now? You have to draw a graph. All right, go on, draw your graph. Okay, we're going to try and draw this graph now. Does anybody remember the SX formula? Count up in what? 40t, was it? So that's going to be, what's it going to be? It's going to be like 0, 40, 80, 120, 160, 200. We know it goes over 7 seconds, don't we? Because we did that already, so it definitely goes over 7 seconds. So what's that? 240, 280, what's the next one? 320, 400, oh, so 360, yeah. Let's keep an eye on the y values now. So how do we get the y values? Sy equals what? 50t minus. Okay, and you fill me out some values here. 0. Next one. 45, yeah. Next one. 80.4, yeah. 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 Next one should be on its way down, I think. Next one. Yeah. Next one. Yeah. 86.4, yeah. Okay, let's go to 10 then. 400 and what? 10. And then finally 11. 440 and bust. Yeah, so I'm going up in 40s now, am I? So I'm going up in, yeah, I'm going up in 40s, am I? So 40, 80, 120, 60, 200, 240, 280, 320, 360, 400, 440. Okay, the y direction wants me to go as high as roughly 125, is it? Okay, roughly 125. Now, how am I going to do this? I think I'll just make it every block worth 10 maybe. 20, 40, 60, 80, 100, 120, 140. I think that's as best as I can fit that in. Okay, let's do our graph now. What are we expecting to happen? What type of formula, what type of shape are we expecting? And to tell me, expecting a bit of an N shape, aren't we? Okay, let's go for it. 0, 0, 40, 45, there, 80, 80, that's a nice one. What's it, 120 and 105? Yeah, about there, yeah. 160 and 21, yeah. 200 and,
127.
yeah, just a bit below 130. 240 and,
123.
about there. Next one,
109.
109, 280 and 109, isn't it? Okay, 320 and
86.
86. Yep. 360 and,
53.
thank you. That really helps me, believe it or not. 400 and 10. Yeah, there we go. Look, lovely. Lovely M-shaped graph. Bit wonky there, but you get the gist, don't you? Okay, not too bad. So that, what angle? Sorry, is this the question?
No, it's okay.
Oh, that's the other one, isn't it? Oh, we're done, are we? Part 4 was the end.
Yeah.